this idea behind it for other people to see what they thought. So I first approached my wife. And thinking about it in context, she and I share a closet. Well, we don't really share the closet, but we have our clothes in the same space. And so I asked her, if, thinking about her clothes, if maybe any of her clothes had shrunk in recent years. And I got to tell you, that's not the type of question you want to ask in 25 years. She said no. And I said, okay. And then I went back to think, I still had a problem now. She was mad at me, and of course the suit still didn't fit. So I ended up deciding to move forward and submitting a purchase order to the CEO of the Yule family, which is of course my lovely bride of 25 years. And much to my surprise, she approved the purchase of a new suit. So I'm happy about that. But she did say, please don't tell anybody about your hypothesis. It's really not a good one. That's my little preamble. But anyways, I'm very excited about this opportunity because I've spent a lot of time studying Cisco in the past. So today, since I have an outline for the talk, I thought I'd start off with a little basic biology about Cisco and some of the methods that we use for assessing the populations. Talk about some of the patterns of recruitment, their spatial distributions, and status and trends of these populations. Provide a little data that I have that I think is pretty strong evidence that adults, in fact, home in Lake Superior. I'm going to switch gears and talk about Cisco as predators and then Cisco as prey. Close with some discussion about recruitment bottlenecks. And then I think at the very end I wanted to talk about some of the restoration rationales I've seen for putting Cisco's back in Lake Huron versus some of our experiences with the species in Lake Superior. So we'll start with basic biology. Female Cisco's in Lake Superior mature at about 250 millimeters or about age 3. The Cisco and Lake Superior tend to grow very rapidly. They'll reach about 300 millimeters in total length by about age 4. At about 7 or 8 years of age, their growth slows, but they can live for an awful long time. These fish here in this particular plot live to about 20 years old. Now, one of the things that's important to note is that because they're long-lived, they tend to have some issues where you'll see the sex ratio skew in the population. So we had opportunity with this thunder bay population to combine commercial catch information with older ages, and we were able to develop catch curves, and from those catch curves we were able to estimate survival rates of males and females. And we found that adult survival of females was 80% on average, while the adult survival of males was lower, about 75%. So you can see that when you play out these survival rates over time, you'll tend to have a lot more large older females than you will large males, adult males. So it's really common in Lake Superior for these sex ratios to become skewed towards females, especially in years following poor recruitment. Did a lot of work early on to determine the best way to assess biomass levels of Cisco and other species in Lake Superior. In one particular study, we compared day bottom trawl estimates of Cisco's versus nighttime acoustics and water trawl estimates. We repeatedly sampled 3 bathymetric contours of the site in the Apostle Islands with these different years. And we learned, and this is for data for small Cisco, that there were no significant differences between the biomass estimates measured with day bottom trawls and the nighttime acoustics. And we looked at these data and concluded that the reason that was is that the juvenile Ciscos perform very deep DVM that puts them on to the bottom during daylight, and thus they're available to the bottom trawl gear. When we looked at the data for large Ciscos, with fish greater than 200 millimeters in this example, we found that there were dramatic differences between the night acoustic estimates shown with the cross hatches and the day bottom trawl estimates shown with the open diamonds. The nighttime estimates were about 1 to 2 orders of magnitude higher than the daytime estimates, which we attributed to the large adult Cisco taking on an obligate pelagic existence. They will drop down deeper in the water column during daylight, but they don't migrate all the way down to the lake bed. So thus they were not available to the bottom trawl gear. Because the juveniles do migrate all the way down to the lake bed during daytime, we were able to assess their recruitment levels based on an annual bottom trawl survey that we conduct in the springtime of each year. On the y-axis is the number of juveniles that were caught These are age 1 of Cisco plotted against the year that they hatched. And so we have a lot of confidence in this recruitment index data because the year classes that we catch in this annual survey are the same ones that we later catch in adult spawner surveys when we age the fish with oldest, and also the same fish that end up becoming very important to the commercial fisheries based on, again, on oldest age estimates. One of the things you should note is that we've seen a decline in the magnitude of recruitment in Lake Superior over this time span. Some of the strongest year classes in the time series were early in the time series. Not only have we seen a decline in the magnitude of the recruitment, the frequency of those strong recruitment events are becoming more and more sparse. I'm going to switch gears a little bit and talk about some of the nighttime distributions. We gathered this information based on midwater trawl catches. There's 2 columns here. I've got the juvenile fish on the left-hand side, the adult fish on the right-hand side. On the x-axis of all the graphs is the bathymetric depth. On the y-axis is the fishing depth, or where we fish the midwater trawl in the water column. What I want to point out is that the catches of juveniles are always highest across these 3 different lake-wide surveys at bathymetric depths less than 100 meters. While the adult fish can be fawned across a much wider range of bathymetric depths, anywhere from 20 meters all the way out to a maximum depth of 350 meters. So pretty much over the entire surface area of the lake you'll find the adult fish. This is the same data, but now I'm using GIS to present it. The 3 different surveys that we've had opportunity to conduct based on midwater trawling, the size of the circles reflects the catch at these sites. The yellow parts of the circle represent the catches of adult Cisco, the blue, the juvenile Cisco. And so during the first survey of 2003-06, we had really high catches of adult fish throughout the whole entire lake. And most of the juvenile fish are caught along the perimeter in the nearshore zone. In recent years, we haven't seen as many juveniles recruit, at least around other parts of the lake, but we have seen a strong signal from the Wisconsin South Shore and the Apostle Islands region. And the magnitude of the catches of adult fish have declined, and you see much smaller circles when you consider these have all been scaled the same. So when we looked at average catches, we did see an increase from 2003-06 for juvenile fish with higher numbers in 2011, and then back to about the levels we had seen in the first survey. This was driven by high catch rates of age 2 fish from the 2009 year class down here in the western arm. And the catches of big fish were hovering at about 5 fish per kilometer of trawling in the first survey, but they dropped to 2 fish in 2011, and they sort of held their own during the 2016 survey. So there's been a dramatic decline in the catch rates of large Cisco during these surveys. We look at the size distribution of Cisco's across the 3 surveys. We had a lot of really large fish present in 2003 and 2006. There have been some strong year classes that recruited between 1988 and 1990. Again, remember the fish could live 20, 25 years. And so a lot of these fish were still present when we conducted this first survey. Now, over time, we've seen a lot of these adult fish drop out. So we have much lower catches of adult fish than we had during the first survey. 2011 survey, again, the strong 2009 year class is represented. They're about 250 millimeters long, and some evidence of a 2010 year class. Doesn't look like there's been much changes here in the catch rates from 2011 to 2016 for adult fish, but we do see less recruits than we had seen in the prior surveys. We take the acoustic information, the midwater trawl information, we can boil it down into an abundance estimate on a lake-wide scale. We estimated during the first two surveys that there were about 200 million Cisco in Lake Superior. The most recent survey of 2016, the estimate was about 75 million. We think this is linked to the change in recruitment patterns with less recruitment in recent years, and the loss of older fish to senescence. We look at biomass, same pattern. We did see just a little less decline between 06 and 2011, but a rather dramatic decline in the biomass of Cisco's from 2011 to 2016. Its current estimate is about 12,000 metric tons. We look at biomass here. This is total pelagic fish biomass. The size of the circle represents the estimate at each of the 50 sites that we're now conducting on our lake-wide survey. The blue portion is what was contributed by Cisco. The pink is rainbow smelt, and the purple colors are a mixture of water and kayak. The thing I want to point out here is that there's been a real dramatic shift in the total pelagic fish biomass from 2011 to 2016. And most of that decline is by Cisco. You see, Cisco still continue to be the most dominant pelagic prey fish, but their biomass levels have likely gone through a dramatic decline to this 5-year time window. Early on, I did also a lot of work to come up with methods to develop acoustic surveys to track spawner biomass. We found a really good correlation between the acoustic estimates of expected midwater trawl catches versus observed midwater trawl catches of spawners. We had an opportunity to conduct surveys during 3 time frames in the Western Arm in July or summer of 2016, October of 2016, and November of 2016. The thing we noted was a dramatic buildup of spawners along the Wisconsin South Shore between October and November. The acoustic estimates of spawners here went up about 6-fold, and the midwater trawl catches of large Cisco and the midwater trawl samples went up about 5.5-fold. So the Wisconsin South Shore seems to be really important, and that is consistent with the recruitment being highest in that region of the lake. We've had an opportunity to carry forward some of these spawner surveys. We've carried them on in 2 areas that support our largest commercial fisheries. These are roe fisheries. They occur in November. The fish are being harvested, the females for their eggs, which is mostly sold in Scandinavia. We haven't been able to sample every year. There's some missing data. The populations haven't been static. Both of these data sets show a strong signal from the 2009 year class. At Sand Island, there's very small smelt, and so we can actually track with the acoustic method sub-adult herring, while in Thunder Bay there's larger smelts, so we're a little bit more conservative in the sizes that we're willing to call adult Cisco. So basically the strong year class of 09, because how we process the data, first turned up in Sand Island in 2010 and in 2011 in Thunder Bay. Some of the most recent surveys that we've conducted here in 2013 through 2015 have been some of the lowest on the time series, which we think is consistent with the lake-wide survey results and also with the recruitment index. So that's it for status and trends and distribution. I'll now move on to some of my thoughts about homing. I took these quotes from a scoping document that I seen for Lake Michigan, and I sometimes see things that leave me scratching my head, and these were a couple of statements that I read. The Arnodai of Lake Superior appears on the basis of neutral genetic markers to be a one meta-population. I think that's true, that the neutral markers do in fact suggest that, but I think there's other evidence that we can bring forward that may suggest that they do in fact form unique stocks. And finally, the typical Arnodai ecomorphotype may not home, and I'm not sure where this was coming from, but I don't agree with that at all. In 2015, I had an opportunity to sample both Thunder Bay and Sand Island. It was a big effort. We collected about 50 midwater trawl samples, 25 at each of these sites. And the samples were collected about a week apart, first up north and then down south. One of the things I picked up on as I was processing the fish, we literally catch hundreds of fish, adult spawners, is that the fish were quite a bit bigger at Sand Island than they were at Thunder Bay. And I picked that up because I had to put far fewer in a 5-gallon pail in order to get that pail full. And when I looked at the lake frequency distributions, I saw that the Apostle Islands fish were in fact bigger than the Thunder Bay fish, which made sense. In fact, they're about 17 millimeters average on average compared to the Thunder Bay fish. So bigger fish in Wisconsin. I then looked at probability that we draw these same means from the same population, and it turned out to be less than 1 in 10,000. These in fact look to be like different populations, to be with Thunder Bay fish returning to Thunder Bay and the fish from the Apostle Islands returning to the Apostle Islands. I also had an opportunity in 2009 and 2010 to conduct essentially the same float plan, where I went out and sampled the same transects 1 year apart to the day. And so one of the things that was interesting to me is that some of the high density areas were seen in both years. Low density areas also coincided, high densities here in the Wisconsin South Shore. To me, it looks like the fish have very predictable spatial distributions at spawning time, which to me is evidence that they do. Switch gears now and talk a little bit about Cisco's predators. This data is very new. It comes from our 2016 CSMI effort. We have broken it up into juveniles less than 250 milliliters and greater than 250 milliliters for adults. Remember, the juveniles mostly spend time at bathymetric depths less than 100 meters. What we see is high utilization of colostrons by these juvenile Cisco. And also, interestingly, high utilization of terrestrial insects. When we looked at adult fish, we saw that the larger Cisco tended to eat larger prey items. We saw higher utilization of mysis and also the invasive predator Bithotrephes. And very low utilization of calanoids based on these lake white samples. I sent this graph to Tom Robick, who's a colleague of mine at Yule, and he was really surprised by that because he has been collecting Cisco samples for a project in the Western Arm, and he found that, and a student found, high utilization of calanoid copepods. So I guess I want to point out that I want to make an admission that in some places, in some years, we do see heavy utilization of calanoid copepods by these large Cisco. I'm going to talk a little about Cisco's prey. It's really kind of hard for us to identify Cisco always, especially when we're dealing with partly digested fish in a lake that has so many different forms of Cisco. So we do what we can. This data I first share is from Ray et al. He compiled from all the state and tribal agencies their diet information spanning from about 1986 to 2001. So this goes back in time a little bit. I'm going to use the same graphs throughout years. It's going to be on the x-axis. Y is the proportion of biomass consumed. Here I'm showing data for both Cisco lake trout and lean lake trout. Pink will be used to show rainbow smelt. The crigginines are shown in black. So on average, crigginines represent about 19% of the biomass of Cisco lake trout in terms of biomass, and a much lower proportion for lean lake trout, only about 9%, with really heavy utilization of rainbow trout in Lake Superior across time. Here I'll superimpose the strong year classes of Cisco. There were strong year classes that recruited again in 88, 89, and 90, and also again in 1998. And when we saw those strong recruitment events, we see in the subsequent years greater utilization of crigginines here and also here where they had been low, big recruitment event, higher utilization. So it doesn't look like we do see a signal when we have strong year classes of crigginines. A little bit more contemporary data. This is provided by the Minnesota DNR. Again, the same color scheme. Here I only have data for lean lake trout. Again, note the high utilization of rainbow smelt by these predators. When we looked at what fish could be identified as species, so we found that the vast majority of the crigginines could not be identified, so they're shown in white. Okay? And the species that could be identified, the species I've shown with different colors. And the thing I want to point out to is that the Cisco are shown here in yellow. So when we superimpose the strong year classes of Cisco, we see there was a kind of a moderate year class in 1998 that doesn't seem to show a strong signal in the Minnesota lake trout diet data. However, the 2003 year class, which was stronger than the 98, does show a strong signal. Again, it takes a couple of years, but you can see several years where, in fact, we did see a lot of Cisco in the diet after that recruitment event. And there was sort of a moderate year class in 2009, and we didn't really see much of it utilized in the diet data. So when the year classes of Cisco appear strong, we do see a signal, but it isn't like the predators completely switch over and eat only Cisco. They get used, but not to a large extent. More contemporary data, we see really high utilization of crigginines by Ciscoette lake trout at present, almost half of their diet. And lake trout is up a little bit, about 16%. We don't have any strong year classes to point out in this recent time series here. When we looked at breakdown of the species, the large Ciscoette are eating a lot of large Cisco, shown in the yellow. While the lean lake trout, maybe about 15 to 25% of their diet of the crigginines that could be identified were identified as Cisco. Okay. Not strong utilization by the lean lake trout. Here we have predator lengths, Lake Superior predators versus crigginine prey length. The line here shows 50% of the predator length. I just want to point out that when we look at prey fish, it can be hard to identify them as species, but we do know that Cisco are really the crigginine that reaches the largest adult size. So any really large fish in this sample almost had to be Cisco's. We see both juvenile, or rather large Ciscoette and large lean trout consuming these large prey. So if you're greater than 500 millimeters total length and you're a lake trout in Lake Superior, you're capable of feeding on the large Ciscos. My friend Jason did work to look at Cisco as an energy vector. We compiled the spawning survey of 2006. We took into account the sex ratios, the link frequency distributions, and fecundity versus link relationships. We were able to cast or to predict how many eggs that population had cast. We compared that to levels of diapry and mysis, and we found that eggs were really a small component of what was available to other fish in winter based on biomass, but when we looked at it in terms of energy density, because the Cisco eggs are so lipid rich, they're almost 35% of the available energy available to fish in winter at this site. We bought fish, white fish from a commercial fisher throughout winter. We saw really high utilization of Cisco eggs by these predators. Some of the stomachs here were completely packed full. I couldn't imagine fitting more eggs in them. We also used the whitefish samples to look at whitefish lipid levels in their liver and also their flesh. And what we saw during the course of winter was an increase in the lipid levels, first in the liver tissue, and then followed by a gradual increase in the muscle tissue. So Jason concluded that Cisco provide a very important service here where they consume zooplankton offshore, package it, deliver it nearshore in the form of eggs, and it gets utilized by fish under the ice. Speaking of ice, we've sort of developed a new hypothesis, and you're probably thinking, oh no, not another Yule hypothesis, even the one I presented about my new suit coat. But one of the things that we do see is that there is this relationship between the recruitment strength of Cisco's and ice cover. Some of the strongest year classes have happened when we've had really severe winters when the lake really froze over. Okay? It doesn't mean that it guarantees strong year classes. I want to point out that there's a lot of year classes that are still around the origin, even though we have really high ice cover. This is really similar to data that we saw for Vendis in a large Swedish lake. They have a different winter severity index here, but you can see when the winters are more severe is when they tended to see the better recruitment of Vendis. We're really optimistic about the recent winters of 2013-14 and 14-15. They're really cold. It would be great if we were to have a strong Cisco year class, but when we went out and indexed the recruitments based on our bottom trawl survey the following springs, we found there really wasn't anything that spectacular about them. So that was disappointing. We recently added larval collections to our bottom trawl surveys. So this is a map that shows all the sites that we typically visit on an annual basis. We do the nearshore survey here in the springtime around the perimeter lake with the green dots, and then in July we sample these offshore areas. We collect, while we're bottom trawling, surface tow, and we count and measure the larvae that we catch. Point out that, again, the most recent year was rather warm. The spring of 2016 was above average, but when we compared to that, the 2 cold winters I mentioned earlier, they were much below average, here maybe average. So warmer temperatures. So we looked at the sizes of larvae that we caught over time. We saw that there were a lot bigger larvae that were caught in the years where it was really warm, in 2016, shown with the black bar. Well, during the cold springs following the really cold winters, there was much slower growth. So the larvae in 2016 were almost 4 millimeters bigger on average. So that's got us excited because maybe these larger larvae will survive better to recruit. And so we're really excited to see what the 2016 year class looks like when we measure it as influence. So wrapping up here, I thought I'd go through some rationale I saw for Cisco restoration based given our experience and the data I provided today. Resiliency through diversification. I think that, yeah, that's probably true. Superior has had, I think, much more stable predator-prey interactions than has Lake Huron, and that's no doubt linked to the diversity of the prey base. Thymines-free prey, I got from Steve Riley's talk that this may not be such a big issue, especially in the main basin anymore, of Lake Huron as it had been, but I just want to point out, yeah, it's true. The diets of smelt and Cisco are lake trout readily reproduce in Lake Superior. Native prey face may be better adapted to the environment. I'm not sure of this because what we're seeing is that Cisco may need ice in order to pull off strong year classes, and we're having periods of less ice than we had, say, even 20, 15 years ago. They are a large body size prey form. This is true. Our lake trout readily consume adult Ciscos when they reach 500 millimeters total length. Can they buffer perch in Saginaw Bay? I don't think this is likely. When we see strong year classes of Cisco, they get utilized, but they're by no means taking over the diet to a point where I think they could buffer any other prey. And do they support recreational and commercial fisheries? Yeah, these lake herring in Lake Superior are readily caught through the ice by ice anglers. Of course, we have commercial fisheries, but you have to keep in mind that when you have fisheries along with that comes with expectations of potential headaches. And that's all I got. Thanks, folks. I just wanted to remind everybody that Lake Superior Tech Committee is going to be hosting the 13th International Gorgonid Symposium this September.